Okay, this is a presentation about welding. Welding is a joining operation. You're putting two pieces, similar pieces of metal together, although there is one type of welding that you could do differently. And what's actually happening is the metals are melting together and you're getting that permanent joint. Um, there's a lot of different types of welding, but the two major ones are using gas or electricity. And one of the things that has to happen is during this welding process, you want to make sure to keep oxidation or rust um, at a minimum. I'll talk about that in a sec. Now, gas welding is a minor manufacturing process. When I um, was working in the um, instrument design industry, we did lots of things with welding, but nobody did anything with gas welding. Um, and I came out here and said, "Oh, it's pretty much dead. Why do you want to have it?" Um, and little did I know, when I got out here, that it's pretty darn useful on a farm. Um, it's very portable. All you got to do is throw a couple of tanks in the back of a truck, and you can go out and weld. And the most common, there's a lot, you'll read about several other types of gases used, but acetylene is the main fuel. When you mix it with oxygen, you improve the heat of the fuel, and so you're heating it up to where you're melting the metal. And if you want to add a little bit of metal to the wells, you have to have a separate filler rod. A little about that in a minute. To have a fire, you got to have fuel, you got to have oxygen, you got to have a spark. Um, even, basic Boy Scout, pre-Boy Scout stuff. Um, and so you're going to, putting in the fuel, the acetylene, you're putting in oxygen to make it hotter, and um, you get the fire going, and since it's a fairly slow process, it's hard for oxidation or rust to develop, um, and it moves out and you just melt very slowly. There's generally three types of flames out of the blowpipe. You'll see them on the next page. The carburizing flame is cooler. It has that long blue flame in the middle, um, and more carbon, i.e., more acetylene, um, and it's useful for things like brazing. I'll mention what that is in a minute. The neutral flame is where most welding takes place. You can see that blue tip in the bottom, the extra blue tip looks like a um, felt marker, and that's the point at which you want to actually do your welding with. When that part is in touch with the metal, you'll get your best weld. Now, the oxidizing flame, you have to look carefully, but that little tip um, flame is actually smaller. That means you got a lot of extra oxygen in this, which means it's burning very hot. Um, if you set it up that hot, you can possibly burn through the metal, or you can use it to your advantage. Look over the names of these parts. Um, I'll be showing you some close-ups of some stuff, but you can see this part is called the blowpipe. You've got your regulator valves, and you typically have the acetylene um, valve is the acetylene tank is uh, most often a little fatter and a little shorter than the oxygen tank. Um, the oxygen, they both run together. One of these shows the pressure in the tank, and one shows the pressure going out. And here's a close-up of the gauge. This part goes out to the tank, comes up, this will read out in um, how much pressure there is, and this is how much pressure is going out the line um, to the regulator or um, to the blowpipe. And this knob out here will change the amount of material going out um, to the blowpipe. And here's what the blowpipe looks like. You can have the oxygen coming in, you can have the acetylene coming in. You get the valves that you open up and let a little bit of acetylene out, and then add the oxygen to it, and it gets mixed in here. And it really ends up mixing right at the very end, not by the valves. A couple other things you can do with oxyacetylene is you can superheat I shouldn't say superheat. You can throw in a lot of extra oxygen and create a cutting torch. And so they can cut big pieces of metal with it. It's been overcome a little bit on the automated part by plasma cutters, but still see a few oxyacetylene out there. All you have to do is change the head, change the blowpipe on a portable rig, and you can have a cutting tool out on the farm away from electricity. Another thing you can do with oxyacetylene is brazing, and it's kind of it's an adhesive process joining dissimilar metals. You can put them together, put copper and aluminum. If you can get the temperature right, you can braze them. Steel with brass, all kinds of adhesive ways to stick metal together with the heat of a brazing rod. You can also do soldering with an oxyacetylene torch. Now, some general rules for safety is, one, you always secure the tanks in a safe way. Keep in mind, if you remember back to that acetylene or that pressure regulator, you're looking at very high pressures, particularly in the oxygen bottles, 30, 40, 50 psi. And if you knock the top off of that, then the bottom half of that tank becomes like a rocket. All that gas, all that oxygen is going to go spewing out, and that tank will go through brick walls. I've seen the results of that going through a concrete wall, and if you look up old Mythbusters, you will actually see that they actually did it, broke the top off, and lo and behold, yes, it did do damage. So you always secure them so they won't tip over, because they tip over, that's when the stuff's going to break off. Don't oil or grease a regulator. The reason for that, you don't put any grease in there or any of the blowpipe parts, is that grease is a fuel, and you're going to run oxygen next to a fuel, and sometimes these regulators can get hot and they will explode. You always turn it on by first turning on the acetylene, igniting it, adjusting the acetylene until that, you'll see, if you ever do this, you'll see a carbon coming out at the very end. And when that disappears, then you slowly turn on the oxygen until you get to that neutral flame. The flame will progress in and just adjust it till it's at the right levels. Oxyacetylene is very bright, it's burning, and there's a point at which it really becomes um, super bright as you're making that adjustment. And it used to be used for lights in theaters and city streets, and um, they were used in the early days of the theater as what they called footlights. They would have this acetylene, they would adjust it to where it was very bright, and these lights were buried in the stage, um, and so they would shine up from the front of the stage to the back, and they would have these lights there. And it ended up being rather dangerous um, because the women at that time wore skirts that went to the floor, and they would walk past these hot lights, and their dresses would catch on fire. And it was kind of like going to a stock car race and watching for the um, crashes as opposed to the race. You need to wear a lens. It's got to be impermeable to splatters of um, molten steel, but it oxyacetylene does not create. It's very bright light, but it is not ultraviolet. So the lenses for oxyacetylene um, are not as strong as the ones that we'll be talking about in a minute for arc welding. Okay, now we're going to switch over to arc welding, and that's where you use electricity um, to create a spark hot enough to melt the metal. That spark is created by electricity, as you know, flows in a path, and when that electricity is jumping across an open gap, it creates resistance, and that resistance um, allows for enough heat to melt the similar pieces of metal and allows them to join them together. Um, now, electricity can use alternating current. It can use DC, what's called straight, where the electrode is positive, or DC positive, where the electrode is negative. It has to do with which way the electrons would be flowing around in theory. Since electrons don't exactly do that, it's not exactly what's happening, but it's you can make those three setups. Now, one of the most common ones is stick welding, or shielded metal arc welding, SMAW, and it uses an electrode, and that electrode consumes itself. It eats itself up as it's burns itself up as it's welding. It's coated with a flux. That flux does several things. It cleans the metal um, because it'll have sometimes have some acids in it as it's moving along. It As it burns up, it creates a pocket of gas around the weld that drives the oxygen out, and then the residue of this burned flux falls down onto the hot weld and deposits a slag, which the slag has to be knocked off after it's cooled down, and um, you want to brush away all the residual leavings of the flux. And there's a lot of different kinds of flux and different kinds of rods. You can see in this picture numbers printed on these rods, and that has to do with the type of flux that's around it. You'll also notice one end is bare, and that's where you would clip into the electrode. And I've got pictures of two electrode holders at the bottom. The traditional one, like we have in our shop, or a twist type, which you stick it straight in. Um, but you have to make connection with that metal, that bare part, that part of the rod that is bare metal. And those numbers on there all mean different things. You'll see a chart like this. And in this class, we use 6013, 6011, and which is different flux, different coatings. And this tensile strength, certain rods are able to create a much stronger weld. A little bit more about that later. And the position means, is it horizontal? Can you use this rod vertically? Can you use it upside down? There are some rods specifically designed to be used overhead. And of course the different current settings. And then the penetration. There's a picture on canvas that gives you an idea of weld, and you can see what they mean by penetration there. And what's happening is you've got the base metal working up, and you would have two different pieces of this, but it's going to be connected to this electrical circuit, that base metal, and the electrons are going to be flowing. And when you have that gap between the electrified wire rod, the rod, and the differently charged metal base, you get resistance for that open gap that causes the metal to melt, and you can see that where it would be melting, and you can see the depth would be the penetration zone, and as that flux burns off, it creates a shielded atmosphere, and it welds. You'll see it in the videos. Okay, a couple of other types of welding. MIG or GMAW welding, gas metal arc welding. It's often called squirt gun welding because the electrode is on a wire and it is squirt out basically onto it squirts out at the same rate at which it is consumed if you do it right. And so that with the stick welding, they're about 8 inches, the sticks are about 8 inches long, and as you go along, they get shorter and shorter and shorter, and you have to put in a new stick to keep going. With the rolls of wire for MIG welding, it's much easier to keep your distance of about 1/8 of an inch because the rod is coming out of the feeder at the same rate that it's welding. Now, there's two ways to create that inert gas pocket. One is to actually bring argon or CO2 or something, some kind of gas. Oddly, CO2 works but the oxygen that's in it is already bound to the carbon, so it won't jump out of the carbon and get onto the metal. But you use this external gas to create the inert gas pocket. So if you do it that way, you don't get a slag, and it's very easy to automate. It's very productive. It's very simple. In World War II, one of the most common jobs for women in the shipbuilding and airplane manufacturing was welding, and mostly they did MIG welding, and mostly they talked about it like cake decorating. You just run it out and weld it away. Here's a diagram of it, and this didn't show it real well. There are some pictures, some videos that show it a little bit better, but that electrode is a long wire. It's a consumable wire. It's run by rollers and pushed out, and you generally bring a gas in from the side, and then the gas creates that weld pocket, and you have your weld. You also can have flux core MIG welding. And what that is that you have, it's hollow wire and it's filled with basically a liquid flux like you have on the outside, like the solid flux is on the outside of the outside of stick welding. And as the metal tube creates the arc and burns off, the flux on the inside then does the same job as a stick welding flux. It creates a gas, and it will deposit a slag on the outside. So you don't have to have separate gases with this. You can, but you don't have to, because it has its own way of keeping the oxygen away from the weld. Another big one is GTAW, or TIG welding, and tungsten arc welding. And what that is very similar to gas welding in how it's done, in that you have a welding stick, has a tungsten insert in it, and then you create your arc with that rod, and that rod does not burn up. Well, it does a little bit, but it won't really burn up too much. And then you add additional wire to it as you want to build it up, filler rod. You do have to have an external source of gas with this. There's no way to do a flux core with it. But you can be very precise. It can do, a good TIG welder will always have welded razor blades together just to prove that they can do it. So it can be very, very precise. And here's a picture of what it looks like. There's good videos on this, showing you some of the different ones. You've got your rod, and you adjust that, and your gas comes in, and then you go at it. Okay, those are the different types of welding, but they all, arc welding, have some very similar issues about safety. And one is that all of this resistance creates ultraviolet light. It will give you a sunburn. It will burn your eyeballs. And so you have to wear what's called a number 10 lens at all times. They have some ones that automatically go into high resistance mode, so that you can see when you get started. But those are fairly new, and it's kind of a lot of real welders don't do it that much, because the amount of exposure is cumulative, and even though it's just a few milliseconds, if you repeat that many times during the day, you'll end up with a whole second of exposure. And like I say, it actually does become cumulative. So you got to wear this big bulky headpiece, and you should wear long sleeves. In our lab, you don't spend enough time with an arc underway that you will get much of a sunburn, unless you are going to do a lot of it. You want to keep flammable stuff away. You don't really want to weld galvanized steel. It gives off some gas. even though we did it a little bit, but just the spot welding you can do, there's not enough of an issue with it when you're spot welding. But if you were doing serious long bits, welding pieces together, you wouldn't want to use galvanized steel. Um, there's some other safety things, but since we're not going to be doing it, we'll move on. Just do want to mention spot welding. You did it when you put your boxes together. And it is actually the most commonly used joining technique of any manufacturing process. I was surprised when I heard that too. Um, because if you think about it, automobiles are often, all the body is spot welded. Major appliances, your refrigerator, your freezers, all of those things are spot welded together. Um, and so there's a whole lot of spot welds out there. It's very easy to automate, and you'll sometimes hear it referred to as resistance welding, but that can be true of any of the stick welding too. Um, you remember how to do it. You have tips that apply current to it. You squeeze them together. There's a squeeze time that they're held together. There's a weld time that you actually run the electricity through it, that you hold, remove the electricity but leave the tips together. You can do lots of things with this that can be done quite um, nicely to get a very nice spot weld. There's a few other types of welding operations. Hopefully these are ones that students will pick for their single manufacturing process assignment. If you haven't seen that, please go to it. Um, and butt or stud welding, that little tip actually becomes the filler rod electrode, and you just punch it into place and welds in place. You can have friction welding, you can have electron beam welding, laser beam welding, ultrasonic, and yes, plastic can be welded. In fact, there's a former student out of our department got his start at one of the packing companies, worked his way through college doing plastic welding, to fix the plastic pallets that the packing house used. And it's very much like um, gas welding or TIG welding, except that you have a little heat gun with a very hot source, and blows in air like a hair dryer, and you fill a plastic rod and heat it and move it forward. Um, One thing about welding is that once you weld it, how do you know if it's going to be strong enough? How do you tell if you did, in fact, create a weld that will withstand the pressures and the rigors that are needed? Well, um, the best way to do it is to take an x-ray of it, just like a dental x-ray. Although the x-ray source is not a little bitty light bulb like tube that's in your dentist x-ray, it is a big hunk of uranium that you put on one side of the weld, because the x-ray beam has got to go through um, steel. But it allows you to have, used to be you'd actually take a photograph of it. Now it's collected on a computer screen, but you have a detector that looks at the x-rays coming out of the weld, and you can actually see little specks in there that are places where the weld did not take. You can also do a destructive test, and that is you take the weld and you put it on a machine, and you find out how much pressure it takes before it breaks, or if it does break at all. It's a little bit like the tensile test, and that's where those strengths are. Those kind of tests, the destructive test, is what's generally done for a welder to get certified. And if after you've taken enough classes and done some specific types of welds, you can there's all kinds of agencies that certify welders. But one of the things that they will do is take the welds that you did and do bend tests to make sure that you did it properly. And that's it about welding. Watch the videos. Yes, this stuff will be on the final exam.